In this video, we will learn how to identify medians of a triangle and using the properties of proportionality to find the missing length. First of all, let's think about what a median is in a triangle. The medians of a triangle are the three segments going from each vertex to the midpoint of the opposite side. Let's see if we can visualize it. If we start with a triangle, the median are the line segment go from the vertex to the midpoint of the opposite side. The midpoint of the opposite side will be the point that divides that line segment in half. The midpoint is here as divides the segment in half, and that makes our first median. For our second vertex, we find the midpoint of the opposite side, and then we draw a line from the vertex to that midpoint. And we have a second median in this triangle. And here is the third one. And at the midpoint, you might notice something about these three medians. The median of a triangle intersect at one point. And this is true for every triangle. The three medians intersect at a single point. They are congruent. The point of concurrency is where the three lines intersect, and this point has a special name. It's called as centroid. The centroid is always located inside the triangle, whatever this triangle type. We will now consider some properties that we find with these medians. We have the centroid theorem, which tells us the distance from each vertex to the centroid is 2/3 of the length of the medians from this vertex. Let's try to visualize this. In this triangle, the three medians have been divided into thirds, and the centroid is P. The distance from each vertex to the centroid is 2/3. And the remaining 1/3 is distance between the centroid and the midpoint. That means the line segment AP is 2/3 of the median, and the line segment PE is 1/3 of the median. We can see here that the line segment AP is twice the line segment of PE. Let's try to write this algebraically. Line segment AP is equal to 2/3 of the whole median AE, and line segment PE is equal to 1/3 of the whole median EE. If we take our second equation and we multiply through by 3, we see that 3 times PE equals AE. Since we found that line segment AE equal 3 times line segment PE in our first equation, we can substitute our new value in for line segment AE. If a line segment AP is equal to 2/3 line segment AE, and line segment AE equal 3 times line segment PE. And we have confirmed what we initially saw was true, that line segment AP is equal to 2 times line segment PE, as you see. Likewise, if we would prefer to say that line segment PE equals half the line segment AP, as 1/3 times 2 equals 2/3, and 2/3 times 1/2 equals 1/3. Using this information, let's consider some examples. In the triangle ABC, M is the midpoint or concurrency of its medians. If line segment AD is a median, then AM is equal to the plank of MD. First of all, we know that the point of concurrency of its medians in a triangle is its centroid. If we wanted to sketch the triangle, try to understand what's happening here, we would need the triangle ABC, and then we could sketch a centroid. We know that the point of concurrency, the centroid, is point M, that line AD is a median. The centroid theorem tells us that the distance from each vertex to the centroid is 2/3 of the median, and the distance from the centroid to the midpoint is 1/3 of the median, of the whole median. So AM, and we want to compare the relationship between MD and AM. To go from MD to AM to get from 1/3 to 2/3, we multiply by 2. AM is twice MD, which means we would find AM by multiplying MD by 2. In our next example, we'll use the properties of median to find the missing side length. What is the length of the line segment CD in this triangle? On this diagram, we can go ahead and identify the line segment CD as here. From there, it might be helpful to write out what our equation. We know that line segment PE is equal to the line segment EC. We also know that the line segment PF is equal to the line segment FA. We know that line segment BD, AE, and CF all intersect at one point. And we know the measure of all line segments AC is 13.8 centimeter. What can we say based on this information? Because the point VE divides line BC in half, this midpoint and the distance from the vertex to the midpoint is a median. AE is the median. That means we can say that the line segment AE is a median. For the same reason, point F is the midpoint, and so we can line segment CF as a median because AE and CF are medians, and the line segment PD intersect at the same point as the other two medians. They have the point of concurrency, which makes the line segment PD also median and tells us that the line segment AD will be equal to the length of the line segment DC. Then we know to find the value of the line segment CD, it will be equal to half of 13.8. Then CD equals 6.9 centimeter. And so we say that the line segment CD has the length of 6.9 centimeter. In our next example, we are given the length of the median, and we will need to use that value to find the length of the distance from the vertex to the centroid. Find the length of the line segment AM given that AE equals 54. Let's see what we can tell from this diagram. The point D divides the line segment AP in half, and the point E divides the line segment PE in half. So we have two midpoints. And we know that A and C are vertices of the triangle, which means the line segment AE and the line segment CD are medians of this triangle. The place where medians intersect inside a triangle called the point of concurrency or the centroid. And we know based on our centroid theorem that the distance from the vertex to the centroid 2/3 the median, and the distance from the centroid to the midpoint is 1/3 of the median. This means line segment AM is equal to 1/3 to the median AE. And since we know AE is the median equals 54, we can say that the length of the line segment AM will be equal to 2/3 of 54. If we want to simplify this, I know that 54 divided by 3 equals 18, and 2 times 18 equals 36. So we can say that the line segment AM measures 36. In our next example, we are given the distance from the vertex to the centroid. We need to find the distance from a centroid to a midpoint. In triangle JKL, JP equals 6 centimeter. Find the length of the line segment PS. We need to know that the length of the line segment PS, and we have been given that GPA equals 6 centimeters. First of all, we should note that the point S divides the line segment KL in half, which makes S a midpoint. Since J is the vertex of the triangle, we know that the distance between the vertex and the midpoint is called the median. And so we can say that JC is a median, GS is a median, and the same way T divides the segment JL and R divides the line segment JK, which means KT as median and LR is a median. Since JS, KT and LR all meets at one point, which is point of concurrency, or we can call it centroid. This is important because we know something about the centroid. For the median, the distance between the vertex and the centroid 2/3 of the median. And the distance between the centroid and the midpoint 1/3 of the median of all medians. To go from 2/3 to 1/3, we multiply by 1/2. 1/3 is half of 2/3. And so we can say that the line segment PS will be equal to 1/2 the line segment JP. Since JP was equal to 6 centimeter, we take 1/2 of that, and we say that the line segment PS is equal to 3 centimeter. In our final example, we will again be given a distance from the vertex to a midpoint, and we will try to solve a missing variable and the distance from the centroid to the midpoint. In a triangle KMH, KQ equals 2 and QP equals 5, x minus 7. Find x. First, we want to look at our diagram and see. We see that the point JPL divides each side of the triangle in half. And then we have a line from each of the vertex to these points. The distance from the vertex to the midpoint is called a median. And that means HL, MJ, and KB are all medians of a triangle. And we know the point of concurrency for 3 medians is the centroid. We can also write down some other information. We know that KQ is 2 and that QP is 5x minus 7 because point Q is the centroid. That is, the distance from the vertex to the centroid is 2/3 of the distance of the median. And then QP equals 1/3 of the distance of KP. And so we can say that KQ is equal to 2 times QP. And QP is equal to 1/2 of KQ. Using the formula QP is equal to 1/2 times KQ, we plug in the value we know for QP and KQ. And we give 5x minus 7 equals 1/2 of 2. 1/2 times 2 is 1, so we have plus 7 each for x equal 8, and x will equal 8 divided by 5, which is 1.6. 8 divided by 5, 1.6. At this point, properly worth plugging x back to find to our 5x minus 7 by substituting x equal 1.6. QP will be minus 7 to solve this equation, so QP is equal to 1. It's true that 1/2 of 2 that 2 is 1 times 2. 1 is half of 2 to confirm the proportionality of our median and confirm that x equals 1.6. Before we finish, let's review our key points. The medians of a triangle are the 3 segments going from each vertex to the midpoint of the opposite side. The 3 medians intersect at a single point. This point of concurrency is called the centroid. The centroid theorem states that the distance from each vertex to the centroid is 2/3 of the length of the medians from this vertex. This means that the segment between the vertex and the centroid is twice the segment between the centroid and the midpoint of the opposite side. Thank you. See you.